Hello everyone. So in our last class we saw that nature loves pattern. There is pattern everywhere to see around us in nature. Today we will have a look at where do we find patterns in our real life, in our day-to-day life. So let's say for example you got a job somewhere or your friend got a job somewhere. Let's say the starting salary is 8,000 and the company said that every year you will get an annual increment of 500. So every year your salary will increase by 500 rupees. So for the first year you will have 8,000 salary, for second year 8,500, for third year 9,000, for fourth year 9,500, and so on. Another example is if we have ladder of such kind where the length decreases. So let's say the length at the base is 45 centimeter, then it reduces to 40, then to 35, 30, 25, so on up to the top. So again we have a sequence here: 45, 40, 35, 30, 25, 20. Another such example is if we count the number of unit squares. If we have a square of say length 1, then we have 1 unit square. If we have a square of length 2, we have 1, 2, 3, 4, or 2 square number of unit squares. If we have a square of length 3, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 3 square number of unit squares. So if you look around, you will find many such sequences, many such patterns of numbers around. It may increase with a constant number, it may decrease with a constant number, it may increase in terms of square, or it may increase as a multiple, or if you divide it by a term or something like that. So in this chapter we will look at one such pattern called the arithmetic progression. The example here is this one where the numbers are increasing with a constant term: 500, 500, 500. This is an arithmetic progression. Or if the numbers are decreasing by 5, 45, 40, 35, 30. These are examples of arithmetic progression. So in this chapter we will look at how do we define a general term called the nth term, or the sum of such n terms in an arithmetic progression. So we will have a look at it. So by arithmetic progression we mean succeeding terms are obtained by adding a fixed number to preceding terms. So for example, we have first term as, let's say, 1, and then we add 1, you get 2, we again add 1, you get 3, 4, and then so on. The other example is we have first term as 100, and then we add minus 30 or subtract 30, then we get 70, 40, 10, and so on. Another is we have, let's say, minus 3, you add 1, you get minus 2, minus 1, 0, and so on. Another is also, let's say we have just 3, 3, 3, so we are just adding 0 or subtracting 0 in this one. Let's say we have something like minus 1, then we are adding minus 0.5 or subtracting minus 0.5, whatever you would like to say, minus 2.5, and then so on. So all these are examples of arithmetic progressions. All of them are the succeeding terms are being obtained by adding a fixed number to the preceding terms. So let us introduce some terminology here. The first term, let us denote it by A, and the common difference as D. So let us try to fill these values for every example. So in here we have the first term as 1, and the common difference is 1. So every number is being increased by 1. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. So we have common difference as 1. In this example we have first term as 100, and every term is being decreased by 30, or we are adding minus 30 to it. So we have first term as 100, and the common difference is minus 30. Here we have the first term as minus 3, and we are adding 1 to all of them. Minus 3 plus 1 is minus 2, minus 2 plus 1 is minus 1, minus 1 plus 1 is 0. So we have common difference as 1. In this case we have first term as 3, and we have common difference as 0. So we are adding 0 or subtracting 0, whatever you want to say. We have 0. And in this case, we have the first term as -1, and we are subtracting 0.5 from it. So we have the common difference as minus 0.5. So one thing to note here is that common difference can be either positive or negative or 0. But for a sequence to be called an arithmetic progression, this common difference should be constant throughout the sequence. Okay, so let us introduce some more mathematical notations. Let's say we have 100, 150, 200, 250, and so on. So we have already denoted the first term as 100, the common difference as 50. Now one more notation that we will use is we will denote the respective terms as T1. The first term is T1 or A, both of them are similar, T1, A. The second term we denote as T2, the third term we denote as T3, the fourth term as T4, and so on. So let's say if we have to represent some n term here, so that will be Tn. So this n could be anything. If n is 1, it is the first term. If n is 2, it is second term. If n is 10, it is 10th term, and so on. So if we notice one thing, let's say we are given the first term a, then what will the second term be? You add the common difference. The second term will be a plus d. Now for the third term, we add d to the second term. So it will be a plus d, or it will be a plus 2d. What do we do after that? We add d to this. So it will be a plus 2d plus d. So it will be a plus 3d. The next term, a plus 3d plus d, that is a plus 4d, and so on. This thing is called the general form of an arithmetic progression. One more thing that I would like to tell you is if we have something like 1, 2, 3, and so on, there are infinite number of terms, then it is called an infinite arithmetic progression. In infinite arithmetic progression, we do not have a last term. Just keep on continuing. Let's say 5, 10, 15, and so on. It will go up to infinite. But let's say you are recording temperature in a week. Then the temperature you may record may be 35 degrees, 40 degrees, 41 degree, 42, 43, 44, 45. So 7 days a week, and then there will be 7 such terms. So this is called a finite arithmetic progression, where we do have a last term. So these are just things to keep in mind. If there are infinite number of terms, then it is called an infinite arithmetic progression. They do not have last term, and if we have a limited number of terms, let's say 7 or 10 or 100 or any n number of terms, then it is called a finite AP, and we do have a last term, and we often call it as L.